So for maybe a coin flip or a dice, I would expect the different outcomes to appear in the same frequency because they have the same probability. If it is a weighted dice, you will quickly see if the 6 appears more often in your sample, then you directly know from that that the dice must be weighted. So the simple average or arithmetic average is our estimator for the expected value. It's the standard estimator. I've added here the caveat that unfortunately that's not a really good estimate, because stock prices and returns are moving quite a lot. Right? If you look at the last few years of the stock market, you have 20% up, 20% down. Right? So using kind of short-term average doesn't work. So for the market return, we usually use very, very long-term time horizons. Like in the US, I think we can get up to 1926, so that would be kind of 90 years of data, almost 100 years now, 95 years of data. Unfortunately, in Germany, we don't have data that far back, so we basically don't have enough data for a reliable estimate. So for discount rates for companies, the historical average return is not a good estimate. And that is why it's one of the motivations actually for one of the theories that we discovered, because we want to link our risk measure to the expected return. Right? So that's better than taking the average historical return. Right? So keep that in mind. If you compute historical returns, they're not good estimators for expected returns. Unfortunately, that's just a pattern in the data. We rather use them to compute risk measures and then link the risk measure to something that's our expected return, using theories. So I think we talked about annualization of returns. Maybe that's an important thing to review here. Typically, we measure the returns at a daily frequency, but the unit of the return will be an annual return most of the time. So remember the two different types of returns that we have. If you want to annualize a log return, that was pretty simple. You just multiply with the number of days. Let me add this here. So the annualization here we have to distinguish whether we're looking at discrete or log returns. And for logs, it's pretty simple. So my annual return is basically just 250 times the daily return. Right? Remember that that log returns are additive, right? So the same holds true for the average. So my average daily return multiplied with 252 is my estimate for my annual return. For the discrete return, we have to use multiplicative compounding, right? So that was slightly different. So here we have 1 plus my daily return. Then take this to the power of, use mu here, not r. Then take this to the power of 252 and then subtract minus 1 again. That would be multiplicative compounding. If you have different frequencies, suppose you have monthly returns, then replace the numbers here with 12 months. Right? So this is always how many of that unit do you have in that unit. So you have 250 days per year, trading days. You have 12 months per year, so replace this with the 12. If you're doing weekly, you have 52 weeks per year, right? So depending on what your frequency is, from weekly to annual, it's 52. From monthly to annual is 12. Right? So it's pretty simple. So usually people express in some research papers everything in the same unit per year because it's easy to interpret. I'm going to show you some data from the German stock market. They're just some numbers that people have anchored in their minds, is that that's the long-term average and that's the long-term volatility of the market. So they can see whether your results are in the good area or whether they're totally far off. So then we have an estimate for the volatility, that's the sample variance. Again, we have a hat here. And also, the return difference here is the same. You now put in your historical mean. Again, the probabilities are gone, and you do this averaging here. Please take care that there is this -1 part in here. That's a reason from statistics to make the estimator unbiased. If you don't do that, the estimator gives you a wrong result. The reason for that is basically that you estimate two things at the same time. You estimate the volatility here and the average return. So your degrees of freedom are reduced by 1, so we subtract a 1 in this division. That's a statistical point, you don't have to worry about it. Here comes into play that Axel has this variance.s formula, right? The .s formula has this adjustment by -1. The .p formula basically does 1 over t. So always use the .s versions, the sample versions, and it's important here for the volatility to get this correct version. And there's also frequency conversion. I did it here with variance. So the annual variance is 252 times the daily variance. If you do this with standard deviations, or volatilities directly, then of course the conversion is sigma hat annual is square root of 252 times sigma daily. Now, this is not an accurate way of doing this, so this is again a shortcut that we take coming from a distribution. So this here is the correct adjustment if your data is normally distributed. Right? So in the normal distribution, the variance is linear in time, is linear in the number of days, and that means that the standard deviation is linear in the square root of the number of days. So if your data is not normally distributed, you're probably making a little bit of an error here. We can have a look at some kind of patterns in the data later. It's relevant when we do theories. You use theories that use a normal distribution, right? So that's kind of the only kind of shortcut that theory has to offer here. So that's why we do this. And finally, there is a quantity, an alternative way of estimating volatility that I just want to mention, the so-called implied volatility. So the volatility is a key parameter in option pricing. We'll discuss that later in class. And the idea is, well, if the option price depends on the volatility, maybe I can observe an option price and back out what the market expectation of volatility is from that. And that's the implied volatility. So you observe an option price, and then you back out, okay, what volatility have people used to compute that price? And the idea is that this is actually a forward-looking estimate, because you use the market expectation of the future here, versus this here is going to be backward-looking. The implied volatility can be observed. There's an index called VIX for the US and VDAX for Germany. You can look up any financial website, you can type in VDAX or VIX, and you see a curve, a time series of the volatility of the market expectations of volatility, usually for the next 30 days. Right? So it's something that's useful and gives you an indication of how the market is currently doing. Right? In the crisis, volatility jumps up, and in normal times, it's rather low. So again, volatility is not something that's constant. It is changing basically every day. Right? It's like market uncertainty, which is in there as well. Let's do a little kind of experiment. And let's see if it's correctly. Yes, so you shouldn't have the next slide, right? Yeah, so the results are on the next slide. So, but I want you to look at this data here. So that's the German stock market index from 1988. So I have kind of 4-year intervals here. And the scale here is, by the way, is logarithmic. So this goes from, it's always times 2. So from 1,000 to 2,000, from 2,000 to 4,000. The advantage is basically that the percentage changes are on the scale and not the prices. If you don't do that, usually you have graphs which look like have a spike at the end, which looks weird. So I prefer this way to keep the percentage changes kind of constant as a scale. Now remember, these are still prices, and all our risk measures are computed based on returns. And my question to you is, what do you believe in which time period we have, which 4-year time period, we have the lowest volatility, and which one we have the highest volatility?
Lowest.
So wait a second, we're going to do a poll so everyone can participate. And then you can share, or everyone, then we can share kind of our thoughts afterwards. So of course this is a little bit tricky, right? So it's hard to actually do this, but nevertheless I think it's important to kind of think about this. So the first question is about the lowest volatility.
Yeah.
Now I'll give you some minutes, and then unfortunately I can't ask both questions at the same time, and then we're going to discuss what the highest is. We have several of these time windows as alternatives.